All right, so now we are ready to go into the details of how the compound interest formula and the future value of an annuity formula, how those two formulas compare. So go ahead and get out the note packet for sections 3.2 and 3.3. So let's go ahead and start on page 1, where we're going to map out an example of compound interest. Okay, let's go ahead and read through example 1. Suppose you open a savings account at Bank of America and deposit $1,500 at 4.8% compounded quarterly. Assuming that you do not withdraw any money and do not make any further deposits, what is your account balance after 1 year? Okay, read through this question thoroughly. Make sure you understand what is going on and what is being asked. Okay. All right, the first thing I want to do is talk about why this is a compound interest problem. Okay, so if you notice, if you read through this problem, first of all, we are familiar with simple interest. That's what we've gone through so far. Okay, if you read through this problem, you do not see the phrase simple interest anywhere. Okay, if you go back and read through the problem, something that you do see is the word compounded. Okay, you see this phrase compounded quarterly. Okay, so since you see that word compounded, that eliminates this from being a simple interest problem. Okay, now when I introduced the formula sheet to you, okay, in the prior video, remember what I told you, this big note I made at the top in red. Okay, all the situations in chapter 3 besides simple interest will contain the word compounded. Okay, so just because you see this phrase compounded quarterly, that doesn't automatically qualify this as a compound interest problem. Okay, it actually is. Okay, so let's go into detail as to why this is a compound interest problem. Okay, so what's going on here is you're going to Bank of America and you're opening a savings account and you deposit this one lump sum of $1,500. Okay, the interest rate is 4.8%. The interest is compounded quarterly, and I'll talk about that in a second. Okay, but you're also told that you don't withdraw any money and you do not make any further deposits. Okay, so you just put that $1,500 in the bank. You essentially forget about it, and then you come back after 1 year and you want to know how much money is in your account. Okay, so remember, you're going to have the $15 to $100 plus any interest that has accrued on the account. Okay, so if you go back to what we talked about when I introduced you to the compound interest formula, so if you look right here, okay, at the compound interest formula, okay, remember, you want to use this formula, A equals P times 1 plus R over M raised to the MT power, if you are saving money and it's a one-time deposit that you put into the account, okay, and you don't make any withdrawals. And that's exactly what we have going on here, okay? You put in the $1,500, that's your one-time deposit. You're letting that money grow for a 1-year period, and you don't take any money out, okay? So that's what makes this a compound interest problem, okay? So yes, we can use the formula to figure out our account balance after 1 year, okay? But for this, our first exposure to compound interest, I'm actually going to map out this problem so we can see over a 1-year period what is going on and how our money grows, okay? All right, so here we go. If you guys look below the problem, I've got this kind of mapping system here. You can see I have the word month, and then I have 12 numbers, so 1 through 12 here, and that just represents 12 months in a year, okay? So you can think of this as a 1-year period that you're saving the money over, okay? So if you notice, the 12 months are broken up. So like I have a vertical line right here before the 1, and then I have another one after between the 3 and the 4, and then between the 6 and the 7, between the 9 and the 10, and then after the 12. Okay, so what's going on here? Let's go back to this phrase compounded quarterly. Okay, let's talk about that. Okay, first of all, let's talk about this word compounded that you keep hearing about, but we really haven't talked about yet. Okay, the word compounded means that the interest is added to the account. Okay, so in this particular situation, the interest is compounded quarterly. Okay, so remember, quarterly means 4 times a year. Okay, and so if you took the 12 months in a year and you divided it by 4, that means every 3 months. Okay, so every 3 months in this situation, the interest would be added to the account. Okay, so that's why I have these vertical lines drawn every 3 months. Okay, so like if you looked right here, months 1, 2, and 3, this is the first quarter, and then months 4, 5, and 6, that's the second quarter, and then months 7, 8, and 9, that's the third quarter, and then months 10, 11, and 12, that's the fourth quarter. Okay, so that's why I have this map drawn out this way. I've taken the 12 months of the year and broken them up into quarters. Okay, so 1 quarter is again every 3 months. Okay, so since the interest is compounded quarterly, at the end of every quarter, the interest will be added to the account. Okay, so that is what's going on here. That's what this whole phrase of compounded quarterly means. Okay, and you'll see in future examples, there's lots of different ways to compound the interest. You could do it monthly, you could do it weekly, daily, yearly, semi-annually. Okay, so you'll see different examples, but in this particular situation, the interest is added to the account quarterly or every 3 months. Okay, all right, so let's go ahead and erase this. Okay, I am going to, just for the sake of simplicity, let's pretend that we opened our account on January 1st. Okay, that's not usually what's going to happen, but just for our purposes, let's make it simple and go from January 1st to December 31st, and that will be our year. Okay, so at the beginning of January, this line is drawn to the left of the first month, which is January. So we're going to say this is January 1st. Okay, and so then January, February, March passes. So let's say at the end of March, that'll be the first time that the interest is added to the account. Okay, so this will be like March 31st. Okay, and then you've got April, May, June. Okay, so this will bring you to the end of June. So we'll say this is June 30th. And then July, August, September, end of September, September 30th. And then October, November, December, that'll bring you to the end of the year, December 31st. That's how we're going to look at this example, okay? All right, so let's see how our money grows. Okay, so beginning of the year, January 1st, you go and you open your account. So what do? You stick in $1,500, okay? So I'm gonna go down to the January 1st line, okay? On that day, what is my account balance, okay? Well, $1,500. That's how much money I put in the bank, okay? All right, well, that money is going to sit there, okay? The $1,500 is going to sit there for the first quarter. So it sits there and it accrues interest through January, February, and March. And then here you go, you arrive at the end of March, okay? March 31st, the end of the first quarter, okay? You're going to get an interest payment, okay? So let's figure out our account balance, okay, at the end of the first quarter, okay? So it's on March 31st, okay? Well, what we have to do is figure out how much interest has been earned during that first 3-month period, okay? So what we're going to do is use what we're familiar with to calculate interest. It's principal times rate times time, okay? So how much money has been sitting in there? That's my principal. Okay, so $1,500 has been sitting in my bank account. Okay, and now I've got to multiply by the interest rate as a decimal. Okay, remember your interest rate up here, your interest rate is 4.8%. Okay, we need to convert that to a decimal. Okay, so that's going to be 0.048. Okay, so that's your interest rate. Okay, and then you need to multiply by the time. Okay, Well, the $1,500 has been sitting in the bank through January, February, and March. That's 3 months, okay? So our time is going to be not 3 because that would be 3 years. It's going to be 3 over 12, okay? So that is what you would do here, okay? That's how you calculate the amount of interest that has accrued during the first quarter, okay? So I'm going to go to my calculator. I'm going to punch this in to get the amount of interest, okay? So let's go to the calculator. We're going to have $1,500 times the interest rate. Oops, hold on. All right, so we've got $1,500 times the interest rate times the time. Okay, and so if I hit enter, this is going to give me the amount of interest that I have earned over the first 3 months. So you can see it's $18. Okay, so this gives me $18. Okay, and so let's go ahead and calculate our account balance at March 31st at the end of the first quarter. Okay, so my account balance is going to be the amount of money that I already had in the account, okay, which was $1,500 plus the interest that I've earned, which is $18, okay? So at the end of 3 months, we have $1,518 in the bank, okay? All right, so that's your balance after the first quarter, okay? So we keep doing this, okay? So on March 31st, this is how much money you have in the bank, okay? So now the $1,518 is going to sit there and earn interest through April, May, and June, okay? And then June 30th rolls around, it's time for another interest payment, okay? So right here at the end of June, okay, we're going to calculate how much interest was earned during the second quarter, okay? Again, you're going to do your principal times your rate times your time, okay? So during April, May, and June, $1,518 was in the bank. That's how much money was earning interest, okay? Your interest rate stays the same, it doesn't change, okay? And during the second quarter here, okay, this is another 3-month period, okay? April, May, and June, okay? So the time is going to be 3 out of 12, okay? So we're going to go to our calculator, okay? And we're going to calculate this amount of interest, okay? So let's go back here, okay? So now we're going to do $1,518 times the interest rate times the time, okay? And we get this amount, 18.216, okay? So remember, we're dealing with money, okay? So we need to round, okay? You can't have 216 cents, I guess. So let's do this, okay? Let's take our number, okay? So let's go back to our notes here. This is 18.216. You're going to have to round this to the nearest cent, okay? So here you go. You've got 21 cents. Look at the number that comes after the 21 cents. So since it's a 6, you are going to bump it up. Remember, if the number after is a 5, 6, 7, 8, or 9, you want to bump it up, okay? So this is going to be $18.22, okay? And then that'll tell you that your account balance at June 30th, okay, that's going to be the amount of money you had in the bank, okay, which was $1,518, plus the interest that accrued during this time period, okay? So you can figure that out. So let's go ahead and take our calculator and do the $1,518 plus the $18.22, okay? And that will give us an ending second quarter balance of $1,536.22. Okay, so let's go ahead and write that down. Okay. All right. So $1,536.22. Okay. That's halfway through the year. Okay. All right. So now this balance, $1,536.22, is going to sit there through July, August, and September. Okay. And that is the amount that will earn interest. Okay. So at the end of the third quarter, so on September 30th, okay, you will get another interest payment, okay? So let's go ahead and calculate like we've been doing. We've got to do our principal times our rate times our time, okay? During the third quarter, the amount of money earning interest is $1,536.22. Multiply that by your interest rate, okay? In the third quarter, July, August, September, that's a 3-month period, so 3 out of 12 is your interest rate, or sorry, is your time, okay? Let's plop this into the calculator, okay? So let's see here. Okay, so this is going to be $1,536.22 times the interest rate times the time. Okay, and again, you're going to have to round that number to the nearest cent. Okay, so let's go back to our notes and do that. Okay, so this is going to be, let's see, this is going to be 18.43464. Okay, again, if we're rounding to the nearest cent, you've got 43 cents. You've got to look after the 43 cents. It's a 4, so that means it's going to stay the same. You're not going to round up. Okay, so it's going to be $18.43. Okay, so let me get that in here. So that's the amount of interest that was earned during the third quarter. Okay, so I'm running out of room here. I'll go ahead and put this up here. My account balance on September 30th is going to be the amount I started with, so $1,536.22 plus the amount of interest earned during the third quarter. Okay, so add these two numbers together. Okay, so let's go do that. Okay, so we're going to have $1,536.22 plus the interest, which is $18.43. Okay, boom. Okay, so you have an account balance on September 30th of $1,554.65. Okay, so let's go put that down. So $1,554 and make sure I got that right, 65 cents. Okay, so all right, so there you go. Okay, so here is your account balance after the third quarter. Okay, all right, so we've got to do this one more time. Okay, because so far the interest has been added to the account 3 times. Okay, so the $1,554.65 is going to sit there and earn interest during October, November, and December. Okay, so then finally the last day of the year rolls around, December 31st, time for that final interest payment. Okay, all right, so let's do this here. Okay, so we've got our principal times our rate times our time. Okay, so it's going to be $1,554.65 times the interest rate times the time. Okay, October, November, December, also a 3-month period, so your time's going to be 3 out of 12. Okay, go to your calculator. Okay, let me go ahead and clear this. We're getting kind of far down there. All right, so we're going to do $1,554 because that's our starting balance for the fourth quarter. Okay, 65 cents times the rate times the time. All right, and there you go. Okay, so here's your interest. Okay, so again, we're going to have to round this. Okay, all right, so back to our notes. All right, so this is going to give us, let's see, 18.6558. Okay, I've got to do some rounding here. I've got 65 cents. I need to look at the number that comes after. It's a 5, so you need to bump this up to $18.66 worth of interest. Okay, so my ending balance on the last day of the year is going to be my amount that I started with at the beginning of the fourth quarter, so $1,554.65 plus the interest that was earned during the fourth quarter, $18.66. Okay, put this in the calculator. Okay, so we've got the $1,554.65 plus that last bit of interest, which was $18.66. Okay, and this is your ending balance. Okay, $1,573.31. Okay, so let's put this in our notes. Okay, so $1,573, and I've already forgotten what I got. 1573.31. Okay. All right, so that's your ending balance. Okay, so that's the final answer to the question, because remember what we were trying to do, we put in our $1,500 and we invested it at a 4.8% interest rate. The interest was compounded quarterly. Okay, and if you look at our mapping, we added the interest 4 different times. Okay, no money was withdrawn. Okay, no further deposits were made. Okay, so the account balance after 1 year, okay, and I'll go ahead and write it so we can see the answer clearly. Okay, the account balance after 1 year is $1,573.31. That's the answer to this question. Okay. So that's what's going on behind the scenes. Okay. You can see that this is a very tedious process. Okay. We mapped out a savings account for a 1 year period with the interest being compounded quarterly. But could you imagine having to do this for a savings account where the interest was compounded monthly for 20 years? Okay. It's not practical to do this mapping every time. Okay. I only did it this once so you can see what's going on behind the scenes. Okay. Luckily, there's a formula that does this for you. Okay. You would pop everything into the formula and you would come up with this answer. But again, I just wanted you to get an idea of how compound interest works. Okay. You put in an amount of money, it earns interest. Okay. And then that money, that initial balance plus your interest, you combine that, and then that starts earning interest. Okay, and then you tack on the new interest payment, and that new total amount starts earning interest. So the interest keeps getting compounded. Okay, so your money grows. Okay, all right, so let's go to the formula. Okay, if you remember the formula sheet, okay, here is the formula right here for compound interest. Okay, let's go ahead and see how this problem could have been solved with the formula. Okay, so if we scroll down below the mapping, okay, it says rework this first example we just mapped out using the formula for compound interest. Okay, so if you look at your formula sheet, the formula for compound interest is A equals P times 1 plus R over M raised to the M times T power. Okay, that's your formula for compound interest. Okay, let's go over what we're looking for and what we know. Okay, let's do the obvious things first. Okay, the interest rate, when you work with the formula, the interest rate has to be a decimal. Okay, so it is 0.048. Okay, T is the time. Okay, we're going back to the original question. Okay, remember, we're not mapping it out anymore. We already did that. We're looking at the question as a whole. You put the money in the bank and you left it there for a 1 year period. And the time value, remember, when you work with the formula, time has to be measured in years. Okay, so we put the money in the bank and we left it there for 1 year. So if you're using the formula, time is 1 because you invested the money for a 1 year period. Okay, all right. P is the amount of the original deposit. Okay, so P is $1,500. Okay, A is what we're looking for. I want the account balance. Okay, so that is what I'm looking for. Okay, the new variable here that we did not see with simple interest is this M value. Okay, so I'm going to write up here, M is the number of compoundings per year. Okay, so M is the number of times that the interest is added to the account over a 1 year period. Okay, so it goes back to this phrase compounded quarterly. Okay, so since the interest is compounded quarterly, it's added to the account 4 times a year. So the M value here would be 4. Okay, so that's what this M value you see means. Okay, if you had the phrase compounded monthly, M would have been 12 because there's 12 months in a year. Okay, or if you had compounded weekly, it would have been 52 times a year. Okay, all right, so I guess what I should do before I plug this in, make sure you understand, okay, so R is the interest rate as a decimal. T is the time in years. Okay, M is the number of compoundings per year. P is the amount of the original deposit, so amount, whoops, of original deposit. And then A is the account balance. Okay, so that's how you can think of this formula. That's what all the variables mean. Okay. All right, so let's go ahead and plug everything in. Again, here we would be looking for our account balance. Okay, we plug in $1,500. That's our original deposit. Okay, so 1 plus R over M raised to the M times T power. Okay, this is how you plug into the formula. You're going to plop this into the calculator and round to the nearest cent. Okay, all right, so let's see what happens. Okay, I'm going to go to my calculator. All right, and so if you're worried about how to put this in, basically you want to plug it in exactly like you see it. Okay, so let's do it. Okay, so we're going to have 1,500 open parentheses 1 plus R over M. Okay, close parentheses. Hit this caret button right here to raise something to a power. Okay. If you have a newer calculator, it will certainly clarify what is in the exponent. But if you have an older calculator and you can't really tell what's in the exponent, you need to be safe and use parentheses to make sure that everything that's in the exponent, you need to make sure everything that's in the exponent is in parentheses, okay? Because like I said, if you have an older calculator, it may not do the exponent correctly. So in that case, rather, be safe rather than sorry, okay? Make sure whatever is in the exponent is in parentheses, okay? Of course, 4 times 1 is 4. We could have done this one in your head, in our heads, but if you had a more complicated M value or T value, you may not be able to do it in your head. So if it's not clear what's in the exponent, then you might want to use parentheses around the exponent, okay? All right, so this is how you type it in, pretty much exactly like you see it, okay? Hit enter, okay? This is the number it's going to get us, and then we need to go ahead and round to the nearest cent, okay? So let's go ahead and jot this down in our notes, okay? So this is going to give us, this is going to be dollars and cents, remember, so, well, hold on, let me do this. We're not quite there yet. So let me erase this dollar sign. Okay, let's go ahead and jot this down that we got out of the calculator. So 1,573.306399. Let's go ahead and round. You can't leave this as the answer, okay? Money has to be dollars and cents, okay? So we have 30 cents. Look at the number that comes after the 30. It's a 6, so that means we're going to bump it up. So our final answer is going to be $1,573.31. Okay, and that is the same exact answer we got from mapping the problem out. Okay, so it makes sense. Okay, so obviously it's a whole lot more convenient to use the formula than mapping something out. Okay, so I just wanted to give you an example. In example 1, I wanted to show you behind the scenes what compound interest is doing. Okay, and now you can see that this formula works, okay, to give us the correct answer. Okay, so hopefully you understand how to use the formula. Okay, so again, you're going to use this particular formula for compound interest if you are saving money. Okay, it's a one-time deposit. Okay, you don't take any money out. Okay, you don't put anything else in, just a one-time deposit. You come back after so much time and you see how much money you have in the account. Okay, A is your account balance, P is the original deposit, R is the interest rate as a decimal, T is the time in years, M is the number of times per year the interest is added to the account. Okay. All right. So now what we're going to do is we're going to jump to annuities. Okay. Remember, I told you in this section, we're going to be looking in detail as to how compound interest differs from the future value of an annuity formula. Okay. So in the next example, we are going to look at the same scenario from an annuity perspective. Okay, same numbers, same deposit, same interest rate, same 1 year time period. But instead of compound interest, it's going to be an annuity. Okay, and we're going to see how it differs. Okay, so let's go ahead and take a look at example 3, which will be an annuity.